Okay, let's start with the official portion of the class. Some announcements. I changed a little bit the rules for the homework, which homework you have to turn in especially. I decided that you need to turn in one of homework 6 and 7. You can choose which one. You can even do both, in which case I consider the highest of the two. But you need to do at least one of them. Okay? I will assign homework 8 very shortly. It will be lightweight. Okay, and so I will drop one of the homework in the series 1, 2, 3, 4, 5, 8. Okay, and so these are the rules. And because some people may not have been planning to do homework 6 or 7, so I postponed the deadline so that they still get a full week and even a little bit more. Okay, and for the people who have trouble doing them, I advise to attend the sections this week as help. So this is the main announcement. Are there any other questions? Also, I was going through my mind at the lecture on tic-tac-toe, and it seems to me that the two elements that really have to be taken away from that class are these two. One is that you wish to communicate state, and the other element is this design principle that I mentioned to you many times, which is sort of my mantra, which is do a little amount of good work, which means don't try to solve the global problem in a single shot necessarily. That is, don't worry about fixing it all and all the possible cases in one go. But make sure that you do a small amount or some amount of measurable progress towards the goal every time you do something, and make sure that you do that something infinitely often, so to say. So this means you need to build a system. So this is a general design principle, right? So it says you should build a system where there are some set of actions that are repeated forever, or at least in an unbounded way. Of course, at some point you may shut off the app, right? But as long as you don't shut it off, you try to repeat these actions. Each one of these actions does not have the duty of fixing the whole problem in a single blow. Okay, this may be too hard, and it also leads to a style of coding that might be quite confusing. Okay, but you should rather make sure that if you repeat these actions infinitely often, so if you leave the app running, if it has enough time, and if it has enough resources, the thing eventually converges to the good state where you want it to converge. Once upon a time, I was working on software verification, and I would write this as a sort of theorem that says, if I had to prove a property of my tic-tac-toe program, I would have to say something like this. If and then you can choose. Do you want to say, if the network eventually will be up forever? And that's too strong a requirement. But I say, if you have an infinite number of occurrences in which both get and post work on the cloud, okay? If you have an infinite number of such occurrences, then the state of the two apps has to converge to the latest state of either one of the two players. Okay, that would be a theorem that I would like to prove of my code. Do you agree with it? So this does not say that in the course of a single contact with the server, every this 2-second deadline, I would try to solve all the problems. Rather, I would want to make sure that if both of the two servers have an infinite number of opportunities of contacting the server successfully, you do converge to a good solution. And then, if this is true, I would even try to prove a bound on the number of communications needed. Okay? So I find it very helpful to develop software keeping these sort of theorems in mind, right? The things that you really want to be true. And one of the good reasons for doing this is that it gives you a way of thinking at the software without actually looking at it, which seems to be funny, but I realized that lately I'm finding over half of the bugs in my code, not by staring at the code, but by thinking about it separately, like under the shower or when you drive the car, similar moments. And that's because when you look at the software, you typically look at a peephole in the software. You look at a very low radius of code. Of course, you know, you're staying inside a function and you're trying to fix the small details of that function. But these global properties, you know, they're not written in any specific place. Either you think about them because that's your idea about the design, or you don't really capture them in your mind. Okay? And I find it exceedingly important when designing systems to have these kind of properties in mind. So this said, my code for tic-tac-toe contains a bug. So the theorem that I just stated is actually not true. Did you have a chance of examining the code and thinking about it and seeing why the code is actually not working the way I intended it to work? Anybody? No, you all took it for granted. I mean, sort of granted.
Does it have to do with the magic word?
Sorry?
Does it have to do with the magic word that you have to use to get a match?
No, it does not have to do with the magic word. The magic word, you know, might have a bug, but I haven't thought about that. So, you know, maybe you should look at it and try to see whether I did it right. But my theorem was intended, once you have chosen two magic words that match, you know, how do you do that? The problem is this. Let me point it out for you. This is the only place in the code where I do a $post. So this is the only place in the code where I tell the server what the new state of mine is. Okay? And so I was thinking about the code, and let's look at where this $post happens. It happens in send state. So where does send state happen? I found, by the way, that one of the main reasons to develop code using an IDE rather than VI or Emacs or anything else like I used to do is that it's a portentous ability, the one of highlighting a place in the code and seeing all the places where you used the particular variable or function. Okay, that alone is worth the price of an IDE. It's the one feature I truly use. So let's see where we send the state. We send the state, you know, we have this process server data function that we use in order to process the answer that we get from the server, okay? And so here there is, well, if we don't get anything, or else if we are still, you know, doing the handshake with the magic word, then we send the state. But otherwise, we do not send it, okay? The only other case where we send it is when we play. And that's kind of why the code works. So, you know, when you play, you send the updated state to the cloud. But if I'm played with somebody, with him, for instance, you know, once I make my move, I send the state once, but all the other states, I pull the state, the two players are already there, so I don't fall in that handshake code, and I never post anything else to the server, right? So what's the problem with that? So now I think I've told you enough that you should be able to see the problem. All the send data here are in this code that does the handshake for the magic words. Okay, so once I'm already playing with somebody, these posts, this send state do not happen. There is only a send state here, okay, that captures, that is called when you play. That is, when you touch the board to play. That's the only send state that happens once we are, you know, in a game. What's the problem with that? Anybody? The TAs can also answer. What's the problem of me sending the state only when somebody plays? Yes.
What if the server doesn't know whether somebody played or something like that?
Yeah, you have the right idea. So the problem is this, you know, I may be playing against him, and then I take the School of Engineering elevator, which is this beautiful metal cage, right? When I'm in the elevator, since it's so incredibly slow, as you may have noticed, I have a lot of time to play, and I play. The problem is that that send state will fail, because I have no network in the elevator, okay? And at that point, I'm left in a nasty situation. I haven't analyzed entirely what happens, but I think it's not good. So what happens is this. I have an updated board, okay? because there is one of my, let's say I'm X, there is one X more now on my board. So it's not my turn, and I won't be able to play again, because I have already played, right? The server will give me a stale state. And because of the code I wrote, when I reconcile the board, it's not here, that code for reconciling the board, but because of the code I wrote here, reconciles to the board, I will notice essentially that the server has an older configuration, and so even though I have one X more, when the server tells me that my X is not there, I will not listen to the server. We designed it that way, and it's correct, this idea of not listening to an older state, right? And so my X will stay there. And I will never be able to play again. Okay, the other player cannot play because it's my turn. Okay? I cannot play because I believe I have already played. And so I will never send to the server the updated state. And so the game will grind to a halt. I might be wrong, okay, because doing this kind of analysis is hard, but I think I'm right. Any thoughts on this? You're sort of convinced I'm right? No? And so the problem is that I have violated one of the things I told you to do. That is, make sure that you do a small amount of progress towards the goal every time you do something. Okay, that is the thing we have to do in order to ensure that the thing eventually works. And I have violated it because when I'm not trying continually to reconcile my state with the cloud server state. Okay? So when I get the server state and I reconcile it with my state, I don't make an effort to then send back to the server, if necessary, the updated state. I do send it once only, and then I don't do any other effort. Okay? So I have completely violated that design principle. By the way, you see why it is very useful to think at these design principles rather than just testing your code. Because if you test your code, good luck me being caught in an elevator exactly when I try to play the X, etc., etc. I would be mostly testing my code while I'm sitting in front of the computer with the two browser windows. So the two players will have the same connectivity because, I cannot cut the internet to one browser window and not the other one easily. I mean, you can. In this developer mode in browsers, there is a way to say, please make network calls fail from this particular tab, or at least I think there is. And if there is not, you can load an extension that I'm sure enables you to do this sort of stuff, okay? But the fact is that most of us don't go to that level of trouble, right? I'm sure that you wouldn't have gone to that level of trouble yourselves while doing the homework, okay? And so this shows the importance to me not only of writing the code, but of reasoning about the code, okay? So now let's try to fix this problem. Yes, but by the way, sorry if I insist on it, but to me, there is one factor that distinguishes the really good programmers from the just, coders that has junk together some code. That is the ability to reason about what their program guarantees and how it actually works. You can do this exercise for a distributed system. What is the amount of good progress towards the goal that you do periodically so that the problems are solved, okay? This is one thing you can think about. But another kind of test that I do often to people, and they're often puzzled, is the following. You take your finger and you put it in a place of the code that is significant. For example, when a loop is over, or when an if-then else is closed, etc. You point the finger there and you say, okay, what's true here? No? So people are used to doing a lot of stuff, but they have to know why they do it and what do they guarantee after they have done it. For example, if they do a graph algorithm, you can point to the finger there and you say, what's true here? And maybe the answer is, all the nodes reachable for my original node are now in that set. No? Something like that. I mean, I don't know what it is. It depends on your program. But if you develop code in such a way that you aim at guaranteeing things being true at regular checkpoints, then that's a much more testable and foolproof way of developing code rather than just writing code that kind of sort of does what it should do, because you remember that the algorithm goes in a similar way to that. No, I mean, I'm not pointing the finger to anybody in particular, but I just tell you that often I notice when people come talk to me that the ability to think clearly about what you have accomplished in the code up to that point and what guarantees you can rely upon in the rest of the code is fundamental. Okay, it's a really important skill. Okay, now let's fix the problem here of the little amount of progress that we don't actually do. How would you fix it? So here is where we reconcile the boards. You see, it's update local variables. It's actually called only from here. Okay, both players are present. Okay, so this is a case in which we don't need to do anything special because we're already doing some amount of good progress, meaning that... I'm sorry, I cannot enlarge this. I can probably do this. I wonder why. Here I'm already doing some progress because I'm essentially saying, okay, I'm playing with the wrong magic word, and the only thing I can do is tell the user to please choose another one, okay? But here I say update local variables, and here is where I fail to guarantee the amount of good progress. So how would you fix it? I mean, there are various fixes.
Problem you were talking about?
Yeah.
Well, when you reconcile the board, you know if the board is older or newer, right?
Yes.
So if you know it's older and it's not your turn, then wouldn't that mean that your send failed?
Yes. So, right. So I think you're on the right track. Let me get the other suggestion in a moment.
Could you kind of set like a time limit on the amount of time in between transmissions and then reconciliations, and then from that, like be guaranteed basically?
I mean, each one of you has a piece of the good answer. If you don't get offended, you have a piece of the stupid answer, which is it's not stupid in the sense of that you are, but in the sense that it's the one that is guaranteed to work with the least amount of complexity. So it's stupid in the sense of positively stupid, meaning that often, you try to be smart, but it's better to be stupid and do the safer thing often than to be smart and get it wrong, right? That's one of the design maxims. And so your solution points to a very interesting solution. So what is, and don't think he's thinking of the more sophisticated fix. And he gave me another version of, but what's the simplest, stupidest thing you can do in order to ensure the property you want? There is a super silly thing that just works, that I wouldn't propose as the thing to do, okay? I want to do something slightly less stupid. But first of all, let's figure out the stupidest one. What's the easiest fix? Keep sending the state. It does no harm. And it's important to realize where the stupid solution works. So imagine that all I do is that at the end of this update local variables, I say send state. And now you may complain because you say, hey, look, this really doesn't work. And in fact, it is a little bit of a silly solution, okay? But let's analyze the gut complaint that you might have. You might say, look, who knows? You are not guaranteed to have the newest state. You reconcile it, and now you are sending it up anyways. Don't you run the risk of clobbering whatever newest state might be on the server? Okay? And I tell you, don't worry. And the reason why you should not worry is the following. So let me draw it a moment to you. Okay? So in the homework I've done, my server is doing nothing on purpose. The reason why I had that server doing nothing is that if the server is completely dumb, you are free to implement whatever protocol you want without having to be, compatible with anything else. No? I leave you the maximum freedom of designing your own protocol. So there is a server that is essentially dumb, no? And then there are these two mobile players. Maybe I've drawn the things in the wrong way around, actually. No, the players are phones, and so maybe they should be rectangles. And the server should be a cloud, whatever. So this is a server, and these are the two players, okay? Now, the whole protocol, so you may be wondering, if we write from here to here, can we be clobbering, overwriting a newer state? I'm not saying anything about that. You might be doing that. But I still tell you that you don't worry. Why? Because the two real actors in this protocol are the two phones. Okay? The server is just dumb, it just writes. Okay? Each phone, because of that reconciled state, makes sure that its own state is not going to be clobbered. So as long as they read and write infinitely many times and they try each time to push the newest state they have to the cloud, the thing is going to work. Okay? The cloud is just a stupid repository. So yes, if I have suppose this phone, let's take away from battleships or tic-tac-toe or whatever we are coding. Imagine that we are coding any game. Imagine this phone has just written a stupendously updated state full of super nice information to the cloud. Okay? Now it's our turn, we know nothing about this update having happened, and we write our much older version of state to the cloud. We would like to cringe and say, come on, okay, you have to at least ensure that the cloud doesn't accept an older state in place of the new one. No, we don't need to worry. This can overwrite the updated state, and we don't care. Why? Because if we continue running the protocol, eventually this phone will get the older copy of the state and will replace it with a newer, right? Because the phones can tell what is new and what is old. And so eventually, these will eventually read the state from the cloud. So it's okay, we are momentarily overwriting the state from the cloud, but eventually, if the two phones keep every time updating the state and keep every time sending it to the cloud infinitely often after having, reconstructed the newest version they possibly can, eventually you can sync. You can prove such a theorem. I'm not proving it, but I think it can be proved. I'm sure.
Wouldn't there be a problem, though, if there was an order thing? Like, for example, if you always had a phone send and then immediately read, it would always clobber. It would be, almost guaranteed to clobber itself every single time.
Good, yes. So what if you send and immediately read without having the chance of reading? Yes. I think that, the things have to happen in a randomized enough way that you enable the exchange of information. And so what do we do? One thing we could do, by the way, we don't have this problem because we are, reading and then sending, which is the loop in the right way. So we are always guaranteeing. But actually you point out a nice point, that is that if we do things in too regular a way, the two phones can end up in some synchronization pattern. And one thing we may want to do to avoid this is make the delay a little bit random. No? Because then you avoid any such patterns. So we are waiting for 2,000 milliseconds. Why don't we wait for 2,000 milliseconds plus some random time? Let's do both fixes. Can some TA look, I forgot, what's the easiest way to get a random number in JavaScript? Do I have to import math somewhere? No. Okay, so let me do that first. I'm sorry, I as I tell you, my memory for these things is very low. Wait, where is it the loop? I think I have this called call interval, and so I can find where I do it. Call server, okay, and I can probably have call interval plus math random. Math floor, math run. Okay, here we go. Goodness. Okay, let me compute it separately, okay? Var extra delay is equal to math floor of math random times max times. So in this case. Okay, this should do it. No? Okay. So add a bit of random delay to avoid synchrony. I mean, I think this is a bit of a paranoid thing to do because the network is delay random enough in practice, but why not? And so maybe we put these, yeah, okay, fine. Now, for the other thing, so I could simply, in update local variables, I could send the state every time. The only reason why I don't want to do that is that, I don't know, it sort of slows down. I mean, if you analyze even the proof why this works, you need to send the state only when you have a newer copy than the one you have just received. Otherwise, there is no real point. In fact, if you do that all the time, you do risk clobbering more often. It's good to have a theorem that things work in the long run. But it's also better if the long run happens faster, so to say. So, if we every time write the state, then suppose, he plays. If immediately after I clobber his move, he will have to fix it the time after, and he will fix it eventually, right? But why delay the game if there is no need? Well, we're really interested, if you look at the proof of correctness and why this works, we're really interested in re-updating the cloud state only if we have a newer copy. Okay, so the stupidest solution is important to analyze to just figure out that it can possibly work. But then we want to be a bit more sophisticated. So what I want to do as the solution that we actually implement is that I want to check whether we have the newest state, and if so, push it. So how do we tell if we have the newest state? So let's look at these. We loop over the board and we say, if our board is empty and the server is non-empty, the server has new information. Okay? Otherwise, I think I would like to add a case here. If our board is equal to empty and server answer board I is different from empty, okay, the server has a newer copy. Okay, and so I have this variable like server has. Wait. What did I do? I wrote twice the same thing because I got confused. I got them the wrong way around, right? If we are non-empty and the server is empty, we have newer state, or maybe device has a newer state. Maybe device has newer state is equal to false. Okay, so I initialize it to false, and so I got my thing complete. The device has a newer state. Okay. And I'm not saying that we have new state all over. I mean, I am writing the code generally enough that, we could have an extra move and the server has an extra move, I don't know. But if we have at least an extra move in some of the places, okay, I say device has newer state is equal to true. Okay, so we remember whether in any of the boxes of the board we have newer state. And I don't know whether this last if then else is useful, but it's basically an error catching condition, so I just don't leave it alone, okay, because I don't care very much. Compute whether it's my turn. Okay, why not? And if we have a newer state than the server, we send it to the server. Okay, and so if device has newer state, self send state. Something like this. Okay, so this should fix it.
Just do the base case.
Eh?
Only at the beginning level, basically. Later on, when we are checking for each and every.
So this is the idea, the point is that this code is guaranteed to run every 2 to 3 seconds now that we put the randomization, and so this code essentially realizes this guaranteed small amount of progress towards the goal, because this alone will not ensure that the two devices are synced, right? It just ensures that essentially we read the state from the cloud and we write back to the cloud the most up-to-date reconstruction of the two states. And if the two phones keep trying to do that, eventually, everything will converge to the newest version of the state. And before, instead, I had this big bag. Okay? Good. So, any questions on these? Is any one of you planning to do homework 7 to try to write this same code in Android? No, nobody is. I don't think it would be so particularly hard. But yes, it would result in, the code would be certainly more verbose. But it would be kind of a good exercise. Okay, so let me send up this code to the server. So fixed convergence bug, a state convergence bug. Okay, git push origin tic-tac-toe. So you have the new code. Great. Okay, once this is done, I want to go to the other part of the class. And I want to look again at animation and painting and drawing, okay, with another example. So I need the Android Studio, so it takes a moment to come up. So let me look a moment at which code I have available here. Okay, yeah, it's the one I want. So let me choose another directory and go in okay, we are in the right place. So this is an example taken from a book about teaching Android. So the first part of drawing the compass is code taken from that book. I think I have the reference when I give you the code. I forgot the title of the book, but it's sort of developing in Android, etc., etc. This was an example in the code that I make available on the web for chapter 4. And I took this example and I added a little bit of animation. Okay, so I originally it was a non-animated example. And now I'm trying to show you how it actually works if we add an animation to it. Yeah, so I am also a little bit out of memory, as you can see. If I continue, I might quit some stuff. Come on. Oh, okay, here it is. Almost. It's still building. So in general, what this example is about is the following. Here we are doing a slightly more sophisticated drawing than last time because I want to draw a circular compass. And if you think at drawing a circular compass, there are two aspects of it. One is that the on-measure, etc. type of functions will have to ensure that my size of the view that I'm defining is a square, right? So the measurements for the two components are tied, and so I just want to give you this as another example. And then because the compass is round and we want to draw, the tick marks on it at regular intervals and the geographical directions, etc., we have to we look at an example where the drawing, when we need to rotate things while we draw them. And I just want to comment a little bit about how that code is done. The original example in the book drew a compass, and that was it. You could at most set the orientation, and when you set the orientation, that number pops up at the top. So you could set the orientation of the compass by looking at the direction sensor. It's one of the sensors of Android. And when you register to it, you get updates, and the updates tell you the angle to the geographical north. There is this magnetic sensor that you can read out of. And in the original example, whenever you get a reading, you make sure that the bearing to the north, that angle corresponds to the angle between the north and the phone with the sign changed on your compass display, right? So that if north is well, yes, essentially. So, okay, now that the build is finished, let me show you, let me give you a demo first. Let me see if I have more memory. Yeah, okay. For the people who don't have memory problems for running the emulator, by the way, I think it works if you define the emulator with a less memory than 1 gigabyte. I think if you have even half a gigabyte of RAM for the emulator, it would work fine. You can change these parameters in the AVD manager. Let me just wait a second until this comes up. Sorry, it's just, also slow. Also for me. Okay. 1 second more. Yes.
When you're formatting stuff on the emulator, and it looks weird on the emulator, but if you load it on a phone, like say like an Android phone, it looks fine. Is that just the emulator's fault, or will that show up on that specific phone's emulator?
So when you say when you turn the emulator to emulate, say, a different model of Android, how will it work on that model of Android?
Yeah. Is it just the emulator screwing up, or is it if I load that phone?
Right, and there is no easy answer. Mostly when you load the app on that phone, it will really look bad. But it does not always work that way. Because sometimes the phones, by other manufacturers, modify the Android operating system. And so the emulator is not always able to accurately figure out what those phones would do. And that's a problem. So when I was developing for Android at some point, I was developing this app that was a bit nasty to develop because it was trying to use the camera in order to record video and analyze the video. And the problem with that is that the camera is designed to take pictures originally, not to take, continuous movies so that you are able to chop into segments to analyze. So it was a slightly different use case. And the software, the camera driver is non-standard in Android. So it's a piece that every phone manufacturer buys and adapts from the camera manufacturer. So when you look at the operating system, there are these device drivers, right? And for cameras, there are some camera vendors, like Sony makes a great share of these camera chips. So maybe, when you have a phone, in the board of the phone itself, there is the camera. The camera has some of the processing inside the camera, that is in the sensor chip itself, and then typically it has a processing unit dedicated to the camera, next to the camera, and that communicates then with the rest of the system bus and of Android. And so they have these camera drivers for each one of these cameras. The problem is that this is a very non-standard object, right? It depends on who sold you the camera and who sold you the driver, etc., etc. So each manufacturer of phones has to decide which camera chips to get, and camera chips are getting more and more standardized because there is so much research and optimization that goes into them that you can recoup the cost only if you make a huge amounts of them. I think Sony is the market leader, but don't take my word for it. But so the story is that Android looks standard. If you say Android 25, it looks standard as long as you use Java. But if you try to do things that are slightly out of the ordinary, then the particular device driver of the camera comes into play, And this is true also for other things if you touch them at a complicated level. So things that are documented in Android and then can possibly work in one way, you start to notice that they don't quite work necessarily in the way they're documented on every possible phone. For cameras, the problems were problems such as, can you take photos while you take a movie? Well, it depends. On some cameras you could, on some others you could not. Would cameras, be able to refocus or report this and that while they were active? Well, it depends. Some of them yes, some of them no. Does the camera thread run in a certain way that you can shut off when you go into background mode? Or can you leave the camera running if your app goes into background mode? Yes or no? Well, again, it depends on the particular way they integrated the device drivers. So this was one source of problems for me writing the app. The other source of problems was the one he mentioned of the graphical layout. And the other source of problems was, and this I think the situation has gotten better just because phones have gotten more powerful, but the other source of problems were that many of the resources of the operating systems were sometimes limited in crazy ways. And you would not discover it until it was quite late. Let me give you an example. We do write all this code using the volley library, etc., as if we are unconstrained in the number of threads we can create. No? We need one more thread for another HTTP call, we just create it. And so at some point I was writing code, there is a function in Android that was called do this in the background. Essentially it enables you in an easy way to spawn a thread and then to look at the results later. Maybe I should cover this function in one of the next classes, okay? And it so turned out that on some particular phone brand, in order to save on the number of concurrently executing threads, they decided that yes, you can spawn these threads, but actually there was only one of them that could possibly run at the same time. So there was no real concurrency between background threads of that kind, and it was not documented. Okay, and it was only me doing experiments that eventually I figured out that I could never possibly have two things going in the background at the same time. Instead of happening in parallel, it would be sequential. And so so this is, in short, the nightmare of developing for Android. I think again now things are better, because the platform has become more stable, more powerful, and so these kind of rough edges that have to do with the hardware limitation are not as easy to meet. But when I was developing, I essentially had on my table a dozen of these phones that, left over from friends, things I would buy from Amazon for $40, things that, passed over by some of my developing colleagues. And I have one of these huge USB hubs in which I could plug them all in. And essentially I would try to see, okay, now does it also work on that phone? Does it also work on that phone? I think I spent a month trying to ensure that my periodic movie cutting capability with cover images for the movies and whatever there is that I was doing was working on all those bunch of phones. Work that now is probably useless because, now that Android has advanced, but this was done 3 years ago, right? And so at that time, what I was trying to do was not very uniformly supported. And this is a thing that I hear from a lot of developers, right? That if you do it seriously because, you need to do it for a job and not because of a class, etc., what a lot of people do is that, they have the latest Google phone, they have the most important Samsung phones. In the end, you need to test these things. Another one is, the Amazon tablet. You can develop for the Amazon tablet. It also runs Android. But it's crazily different in ways that are, documented if you go on Stack Overflow. But for example, the orientation landscape on an Android phone is turning it, I think, one half turn counterclockwise. And on an Amazon tablet is half turn clockwise. So if you just know that your landscape and you lay out stuff on the screen by absolute pixels, you display it upside down on the tablet, right? Things like that. So in practice, it seems you actually need to test these things. Now, let me go back to the Compass application. It doesn't look very great, but it displays a compass. And so the original version of the app, when you press the button, it would just set a particular orientation on the compass. In theory, we should read from the magnetometer, but I don't have a magnetometer in the emulator. So in theory, you should read from the it would simply set a location. And what I did is instead, I built an animation that mimics a bit of the magnetic force on a compass that turns it into the right direction, that is opposed by a bit of viscosity in the fluid in which the compass is, that breaks it until it points to the right direction. If you have a nice compass of the physical old style, those compasses used to be in an oil bath, right? They're not so expensive. You can still buy them easily. But so the needle tends to align with the magnetic field, but there is the viscosity of the oil that sort of dampens the oscillations and then lets it settle in the right direction, okay? So I wanted to mimic the behavior of an oil compass, and I did exactly the same principle as we have already seen in the previous application. So, I have a dynamics class that will give me the dynamics. So let me look at the code first. This is the code for my activity. That calls sensor set bearing. You see, actually, I do the work of getting the sensor service, the rotation vector. So if you run these on a phone, you should be able to see that the compass is smoothly updating, okay? But in order to be lazy, I also have the button that causes the set bearing to 60 degrees that enables me to test it more easily when it's running in the emulator, okay? So the only thing I'm doing in this main activity, it's incredibly simple what I do, right? Because the compass view is a view, and so it's included in the layout. I don't need to worry about the compass view in the main file, right? The compass view has its own dynamics and drawings defined inside the view code. In the main code, the only thing I do is this. I get the sensor service and I get the updates. And when I get the updates, I get my compass view and I set the bearing to it. So my compass view will have a new method called set bearing, which will set which compass heading should be on top. That's it. Okay? So very, very simple encapsulation in a sense, because the whole code happens in the view. And then, I just added a button. Okay, and then the only thing that I do on pause is that I remember to unregister the updates. Actually, let let me give you one more piece of information regarding really the software engineering. Here, I decided. Actually, the author of the book from which this code here is essentially copied from is not copied. It is from the book. I will give you the reference when I post it. Okay. When I register a listener to a sensor, I have to implement a certain interface. So I have to have these two methods: on accuracy changed and on sensor changed, right? These are the two methods. And in the code I've given so far, I've given you another way of doing it. So essentially, I told you, okay, let's implement a new class that is a sensor listener, and let me override the two methods, right? This is what I've done in the past to, for example, read from the location, okay? Everybody remembers this, right? I say a new location listener, and then I override the method on location changed. That's what I did. There is another way of doing. I don't have a preference for the two ways, but there is another way of doing it. The other way of doing it is this. Here I'm defining my activity, and I'm saying that my activity extends activity, of course, but also implements the sensor event listener, which is an interface in Java. This is essentially saying that my activity implementation itself will implement this interface, and so can be used as a location, as a sensor listener. Okay? So if I do this, if I promise to implement this interface, sensor event listener, I need then to implement these various methods. For example, look at what happens if I remove these. Okay? I can do this, and then I get an error. And if I look at the error says, class my activity must either be declared abstract or implement the abstract method on accuracy changed. Okay, because otherwise it's not a correct implementation of the interface sensor event listener. Okay, so that's why I have, that's why I need to define this do nothing method. Okay, so. If you do that, the onSensor changed can be just written as one of the methods of your activity. So which way is better? Is it better to define a new subclass or to define your activity that implements the interface? I don't know. It's a matter of taste. In the code I write, I generally use a new subclass. I don't like to have my activity class implement all these kind of interfaces because I always worry that some of these interfaces might share some of the same methods, right? What if you want to listen to more than one sensor, and then these on-sensor change the callbacks would clash? And it seems to me to be, a bit of and not in the best style of coding, but it is a very common paradigm for writing for Android, as long as you don't get into clashes in this way. Okay, so the on-sensor changed method is a method of the activity itself, and when we run on resume, we register the listener, and the listener that we register is actually called this. So it's the activity itself. Okay? Just for to present different ways of writing the code to you. So the interesting drawing code, it happens in compass view. Okay, so this when you create it, I call this init compass view. This was just done to move the code, the complicated part of the code aside. So you see that in the initialization, what I do is that I define as much of the paints as possible that I will need for actually drawing the compass. I define this circle paint, which is used to draw the circle where the compass is. I define the various strings for the cardinal directions. I have the text paint, the marker paint, defined there, etc. Oh, is the font big enough? Okay. Now there is the on measure. Actually, our measure here is very simple. It works in this way. So I want a square region, and I want it to be as big as possible, okay? And so I have to do two things. First, I have to figure out how big is as big as possible in the vertical and horizontal direction, and then I have to take, of course, the minimum of the two to make sure I fit into that, okay? So this measure function that I have highlighted measures for width and for height what's the biggest I can possibly get, okay? The code is factored together in this measure function. And so it says something like this, it gets the specification mode and the specification size. You know that the mode can be essentially the equivalent of fill parent, wrap, view, or, unspecified. So if they don't tell me how big, I'm 200 pixels, just because. Otherwise, we return the specified size because we try to always fill the parent as much as we want. We don't have a wrap content mode, because there is no content in a compass that we need to wrap, obviously. Okay, we just need to be a compass, I guess. So if they tell us a size, we have that size, and then our size. So the trick is this: that we get the minimum of the size for the width and height, and then we set our measure dimension to be that size, both in vertical and horizontal. So that's how you can enforce a square view. And if you want, views of other aspect ratios, that's how you can do it, okay? So one more example of this on-measure method that we have to implement. The other method that we have to implement is on-draw. On-draw is the method that will draw each time on the canvas, okay? Let me look at one variable above. Sorry if I flip so much around, but no, so sorry. Fine, sorry. So this is how drawing works. I still think this font might be a little bit small. Oh yeah, in fact I have this style teaching which is a little bit bigger. Okay, so Px and Py is the center of the circle. This is the radius, okay, it's the minimum of, the distance from the center to the two various edges. We draw the circle, and then okay, we start to essentially. There is something that I never quite understood in graphics, but some people are able to explain to me, I'm sure. So, if you need to draw things that are rotated, there would be two choices in my mind that are obviously equivalent. One is you take what you want to draw, you rotate it, and you place it where you want. But that's not what's done, okay? What is done is different. What is done is this. Imagine you are writing by hand, actually, and that would make sense to do it in the other way. There are two ways. Imagine that you are writing some nice lettering on a sheet of paper, right? You can either keep the sheet the way it is, rotate yourself and write at an angle, or else you can rotate the sheet, but you can still write in the orientation in which you are used to writing, okay? The two things are obviously equivalent, and from the point of view of coding, you can obviously write the code in both ways, in theory. But for some reason, which I don't know if it depends on the fact that if you're a real graphic artist, you would rotate the paper rather than rotating yourself. The way you do these things on a canvas is typically that you rotate and reposition the canvas, but you always put the things upside up on it. Okay, and so the change of orientation is due to the fact that the canvas rotates. So north is not what is on top. Okay, there is another bearing that will be on top. So what I'm doing is this. I'm calling this getBearing method. We will see later what this getBearing method does. Okay, But this get bearing method tells me what I have to draw on top, okay? And I start by rotating the compass so that in the opposite. So sorry, I have this rotational. There are two things I get wrong: indices of matrices and signs of rotations. Okay, but if you want that 60 degrees is on top. Oh yeah, it's because of the way angles are measured, right? Because wait. Yes, suppose you want 60 to be on top. Okay, so 60 in a compass is here. So what do? You rotate the compass of the negative angle 60. So you rotate it in this way, okay? So then you draw the north, etc., 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 okay? So you want 60 to be on top. So you start rotating the sheet. Then on the rotated sheet, so we have done the first rotation in this way. This is the first rotation, okay? Because we rotate negatively, and negatively in mathematics, is clockwise. No, counterclockwise rotations are the positive. So we rotate negatively by 60 degrees. Then we draw the compass, north, south, etc., etc. At the end of it, we will re-rotate the canvas back. So we will do this other rotation. When you do this other rotation, the north will rotate here, and the 60 will rotate on top. So that's the idea. That's why there is this negative sign in the rotation there. And that's why there is this save canvas. The save canvas, if you see the instructions, essentially saves the position of the canvas, so that when you do a canvas restore at the end, or canvas canvas restore, yes, right, you undo the original rotation. So it's a bit unfortunate in reading this code that these canvas save and canvas rotate make sense only in the context of the final canvas restore. I mean, I think you have to sort of learn it a little bit, okay? It's a sort of idiom that you do. But if you need the whole thing to be rotated, you save the canvas, you rotate it to start drawing, and at the end you restore it, okay? So that's how to read this pair of code, this piece of code. Once we are here, I could add a comment that says, okay, now we can draw with the north up, okay, which simplifies to a great deal our mental problem, okay, because we are not rotating, not trying to draw a compass in arbitrary orientation, but now we are trying to draw the compass with the north up. So here we measure how big is the text, okay, because we want to know how big it is in pixels. So we do some math to know how big things should be, etc., etc. And then we start a loop in which we draw a mark every 15 degrees. So I will go from 0 to 23, counting how many ticks we have to draw. And so we do something like this. First we draw a line, then we save the canvas, we translate by text height. This is done in this way. I mean, you could do it in a different way, okay? But the authors decided to do it in this way. What they're doing is this. They draw the tick mark, then they translate the canvas, and they draw the letter, except that the canvas has shifted up, and so the letter will be below the tick mark. You could say they could just draw the text in a shifted position, okay? Fine, in fact they could, but I don't know why they don't, and this is another choice of doing things, okay? So they essentially draw the tick mark, save the canvas, translate it a bit up, then they draw the cardinal points, if they need. And then they do this restore, it's not this restore, which essentially reshifts up the canvas a bit. Okay, so all this code here is done with the canvas shifted down a little bit down, so that you don't draw the tick, but you draw the symbols below the tick. Okay, then you rotate the canvas by 15 degrees around this point. Okay, so you see the loop. If you forget about what you draw below the tick, what you do is this. You draw the tick mark, you save the canvas, you do some mess to draw the lettering below the tick mark, you restore the canvas and you rotate another 15 degrees. So you can save and restore. It works like a stack, There is a stack of saved canvases. They're not really canvases, but it's kind of like canvas positions, right? There is like a stack of those. And you should have called it like something like, push and pop, I guess, if you wanted more common terminology. But they called it save and restore. Okay? So now you can look in detail at what they do in the code for drawing each cardinal point and strings. But it's quite easy, because it says, well, if I modulo 6 is 0, this means that I am at one of the cardinal points, and what I have to do is that I need to draw a bigger line, because let's see how it looked, right? No, actually, yeah, it's a bit unreadable, by the way, this compass. What is it? I don't see these lines, actually. Oh, this is the line for north. This is trying to draw these two lines, this arrow there. Let me see if I can magnify this view a moment. So if you look below the north, there is this arrow, okay? And this arrow is drawn here. And otherwise, they just draw the string. And otherwise, at the other positions, so if this is I modulo 3, so at 45 degrees, they get the angle and they put the string for the angle. They draw the 45, 135, 225, etc. Okay, so but you can essentially walk through that code carefully and see what they draw. At the end of it, they restore the canvas. Okay, so this whole code is done by saving and restoring the canvas. I think it's useful to see it. So that's the code for drawing. That's the code for measuring. We have already looked at it. That's the code for initialization. Okay, and that's all there is to it, almost. Okay. It's almost all there is to it. And so it's everything that was in the original book example. And then I thought, look, let's do the same change. Originally in the book, the idea was that you set the heading and, zook, the compass immediately goes to that heading and that's it. And I wanted to give it a bit of a fluid dynamics. And I thought, well, this is exactly like what the other tutorial on the web does. The other tutorial, which I truly recommend reading, was starting from the code that displayed that graph, then added a dynamics to each point, and animating the dynamics would give the behavior. And so I said, well, I can do the same, right? Instead of getting the position, instead of having the heading being a floating point number, I can have the heading of the compass be a dynamics object. Okay? The heading will be a dynamics object to which I can set the direction of the magnetic field. Once I set the magnetic field, the compass will try to align itself with the magnetic field. Okay? And to know the heading that the compass should point to at any given point in time, I use this function that is called getBearing. Okay? This function getBearing returns compass dynamics.getPosition. It's, the change I did to the original code of the book that you can find in the repository when I did the change, okay? But originally the book had a floating point number for the compass heading, and I replaced it, the floating point variable, with this get bearing method, so that each time you call the method, you would be able to get a different bearing. And then, exactly as in the other example for the book, I want to be able to schedule computations of the bearing. This dynamic object will update its state internally, okay, according to how much time passes. And I want to be able to schedule computations of these dynamics until the compass is settled. And so I wrote exactly the similar code. In fact, I think when I developed this code, I essentially cut and pasted it from the code of the tutorial into here, right? And then modified it to fit the purpose. And what I did is this. I created a runnable animator. If I expand this, it's a new runnable with a method run. There is a Boolean variable need new frame, a long now, which is the time now. So I updated the dynamics. If the compass is not at rest, then I need a new frame. If I need a new frame, I post delayed to the UI thread. I do another post of a runnable. That is, I ask that this runnable is run 20 milliseconds from now, and then I cause a redraw. Invalidate, I know, it always hurts my feelings, this stupid invalidate. It should be called redraw or something like that, right? But by invalidating the current view, it triggers a redraw of the compass, okay? So this is exactly the same code that we saw last time, okay? We ask for a new position, we redraw itself at the end, I guess. We redraw itself at the end, and if the thing is not yet at rest, we reschedule this same runnable in 20 milliseconds so that it's able to update the position of the compass, okay? So this is for get bearing. What does set bearing do? Set bearing happens when you get a new reading from the sensor, or in the case of the demo, when I push the button, there is the set bearing call. Set bearing simply tells the dynamics of the compass. It tells it, this is the new direction of attraction of the magnetic field. No? This is a new position to which the magnetic needle will be attracted. Okay? And then I schedule immediately a run to the animator. And in this case, I have a bug, okay? Because what I should also do, and let me fix it, is also that I should remove previous calls to the animator. Okay, so how do I do that? I forgot. Can anyone look at it was in last week's code, but it's sort of a remove calls, remove callbacks, I think, animator. If Atiye can please check that remove callbacks is what I need, then I would be happy. Okay, I didn't realize I had this bug. Okay, well, maybe check in the background and then let me know if it's a mistake, okay? In the meantime, I go to the dynamics object. In the dynamics object, what I do is this. Again, I have, just as before, it's like a modified Springer compass in a magnetic field. So I have a target position, I have a position, I have a velocity, because I'm going to model it with a bit of, really with the dynamics. Last time, springiness and damping. Damping is the damping constant of the fluid. And so, I have various constructor methods. Okay, in which I try to set the damping to something reasonable. Okay, there is set velocity if I want to use it. Nobody uses it, I guess, whatever. Set target position. I think I played a bit with these. Okay. But the interesting method is the update. So how do I update the position? I do the following. I compute the angular difference between my position and the target position. Okay. The acceleration is the springiness, so the intensity of the magnetic field in a way times, how the magnetization of the needle. This is an arbitrary constant. I didn't want to measure fields in Gauss and whatever. And then I do multiply it by the sine of the angle difference, okay? Because we are in a magnetic field, so actually, did I get it right? I think I didn't. No, the sine. I don't think it's a sine. You know, all the errors you look when you... So, if you are in a magnetic field, let us think at it a moment, okay? So, suppose that the direction to which we are attracted is this one, and suppose that instead we point in the needle points in this direction. What is the force proportional to? No, I think I'm right, actually. Because it's the derivative of the cosine, so it's a sine. Sine, yes, I was right. I did the math correctly. Okay, so this, this is actually the correct formula. Okay, and so the acceleration is equal to the spring constant minus the damping times the velocity. Okay, these fluid frictions are generally proportional to the velocity, to the angular velocity in this case. Okay, and so there is a damping factor to the acceleration, which has, you know, the minus signal because it goes in the direction opposite to the velocity. Okay, so once I know the acceleration, I know that the velocity is equal to the acceleration times the delta t. And the position is incremented by velocity plus delta t. So this is, a fairly horrible way of doing integrals. No, what I'm doing is I'm integrating a differential equation. Okay, and this is a way that is guaranteed not to work well. No, because it's as if you are computing an integral by always underestimating. You know, this is the rectangle method of computing the integral, because instead of trying to fit the curve better, you know, instead of trying to update the velocity according to a better version of the acceleration integral, I'm using this sort of rectangles view, now that will go like Zach. You must have studied in calculus this way of approximating integrals with rectangles. So if my goal was of writing scientific software, I would use more sophisticated integration routines. And there has been an incredible amount of incredibly nice work on integration routines. The fact is that here we don't need to be perfect, right? This is just animation, and we just need to look plausible. So for all these animations, integrating with rectangles is fine in the end. We don't really want to model the behavior of a real compass to a high level of precision. So here I'm essentially doing the integration by rectangles, and I have a method is at rest that simply. So when is it that you are at rest? There are two conditions: that you are not moving anymore, and that the bearing is correct. Both of these conditions need to be true, because, you know, the compass might have the right bearing, but it might still be moving, or it might be stopped at an extremum of the oscillation, but it's not pointing to the right direction. But when both velocity and displacement are right, then you know that you are going to be at rest, because the acceleration force is also going to be zero. Okay? And so this is a simple implementation. Okay? And then there is these other methods, get target positions. I mean, I think I built a dynamics object that was more general than needed. It has all these various methods. But the essence of it are these methods. Set position, which simply sets the new target position. Set velocity if I want. I don't think I use it. Set target position. And then this method that is, that updates itself. And so this generates the animation. So that's a very, very simple and general method. It's only that here, unfortunately, I don't have a sensor in order to pass it readings. But if you run the code that I give you on your phone, you will see that you can rotate the phone and the compass, smoothly does and then goes into the new orientation with its own, the speed of attraction of the needle and damping. Okay? So that's all I wanted to show you today. What I want to do next time, I want to do a sort of overview of the sort of remaining difficult things to do with Android. Because I'm always wondering where can I give you the highest value added, compared to you just reading the documentation. And it seems to me that one of the biggest hard things to do at the beginning is to understand now how to organize background activity, that is services. In Android, we have activities that are these front-facing things that you can stare at and have behavior. And then you have services that are these things that run in the background, possibly for long amounts of time. You can see, if you go to the apps section of your phone, you can look at the running apps and you can say, okay, two activities and one background service, right? So doing those is complicated because they need to be initiated and they need to be rendezvoused in order to exchange information in particular ways. And so I want to go into how to make them. I realize, many of you may tune off because there will be no homework on background services. If I gave one, it would be a complex one, and we are at the end of the class, and the homework 8 is going to be on animations. So I will ask you some questions in the final, but I will not have a specific homework on these. However, I believe that if you keep this material for reference, when you have to really write your own Android apps, it may come of value to have a full example of how to do some background activity and communicate with it. Because it's maybe now there are more. When I first wrote these examples, there weren't so many of them that were complete. And so I think it's a valuable thing to have. Okay? So I want to go into the background services implementation. I'm not sure whether it will take 1 or 2 classes. Probably 2, because I also want to talk about the inter-thread communication. Then we have the last class that I haven't yet decided what to do. Okay? If there is any suggestion, but otherwise I will announce later the topic. Okay, so that's the program for the remaining classes. Okay, questions at this point on this animation and on this compass? Yes?
Not on this, but are there going to be project presentations?
Yes, the project presentations are Wednesday after the final, from 12 to 3 and from 4 to 7. I could ask actually for the last class if there is some project that wants to present early to be done before finals week. I could host a few project presentations. I've done it the last year. Some people were happy to take advantage of the option. So I think I will do it also this year to look at a few project presentations before. Okay, thank you.